Okay, we're going to talk about polygons and angles of polygons, if I can get this thing started. All right, here we go. Two-dimensional shapes. All right, polygons. Well, don't read all that. Just look at the pictures. Okay, what do you notice is true about polygons on the left and these that are not polygons on the right? Excuse me. Okay, one thing we notice is that they're connected all the way around. Like this one has an open space, so that's no good. All of these are connected shapes. Okay, this one that has a non-example is because it has a curved line in it. Do you notice any curved lines in polygons? No, they're all straight lines, segments, right? Little segments. And then why is this one not a polygon? I mean, you could say it's two polygons, two triangles connected, but you can't cross a line and have this be one polygon, like some hourglass shape or whatever, okay? So that's not a polygon. These three are polygons, okay? All right, what's a three-sided polygon called? Let me see. I guess it's a triangle. Four? Do you know this one? Quadrilateral. Quad means four. You have quadriceps in the front of your thigh, on your thigh right there. You got four muscles right there on your thigh called, quadriceps. Anyway, quadrilateral. This includes a bunch of different types like trapezoids and squares and rectangles and rhombus and kite and so many more. Okay, five is a pentagon. Six would be a hexagon. Seven, heptagon or septagon. I've heard them both. Heptagon, septagon. Eight is, of course, the octagon. Nine is nonagon. Not nineagon, but nonagon. It sounds weird, whatever. And then 10 is a decagon. Deca is like for decimal. Decimal is a 10-digit system, deca, deci. Anyway, decagon. And then 12 is a dodecagon, okay? And we're going to like the 11, the 13, 14, 15, 16, 17, 18, all the way up to millions, we're going to use n, which means side, and put GON next to it. So, in other words, it could be a 17-GON or an 11-GON or a 23-GON. Strangely enough, online you can find names for all of them, but we're not going to do that. Anyway, we don't need to memorize names. We need to know how to work these problems. Okay, so 13-GON, you get it? That's a 13-sided shape, a polygon. All right, next. You can have convex or concave polygons. Okay, this one is the one on the left, the blue one, is a convex polygon because all of these little angles right here are pointing outward, or they're outies. Like belly buttons, they're outies. Okay, and if you put lines through every side, none of them will go inside the shape. So that's a convex polygon, all outies. Okay, this one right here, if you put lines through it, obviously it'll go through the shape. So this one is concave. It's got a caved in part. See these caved in parts? Okay, caved in parts, concave. Kind of like glasses. The outside of your glasses is convex, and the inside of your glasses towards your eye is concave. It's got a little caved in kind of part. All right, a regular polygon. Okay, that word regular means something here. Okay, it's a convex polygon, first of all. All the sides are congruent. All the angles are congruent. Okay, so that's a regular polygon. If all the sides are congruent, all the angles are congruent, and it's convex, then it's a regular polygon, like a regular hexagon. Okay, a regular hexagon. Here is a regular hexagon. Question, is it convex? Yes, all the lines, none of them go through the inside, so it's convex. Yes, it's all outies. And then are all the sides congruent? Yeah, they're all four. Okay, so the sides are congruent, and then the angles are congruent as well, right? They're all 120 degrees. So this is a regular hexagon. Regular means these three things. Okay, um, so that's a yes. It's a regular hexagon. Yeah. Okay. Now name this polygon. It's got four sides, so it's a quadrilateral. B, is it convex or concave? It's got all outies, right? Angles are all pointing outwards, so it's convex. And then, is it regular or irregular? Obviously, it's irregular because all the sides are different lengths. Okay? Name the polygon. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got 9 sides, so it's a nonagon. Okay? Convex or concave? Now it's got a caved in angle here, caved in part, so it's a concave polygon. And then, is it regular or irregular? Well, it's obviously very irregular. Okay, all the angles, all the sides are not the same. Okay, and it's not even convex. Okay, interior angle sum. Okay, that's very important. That's the sum of all the angles on the inside. Okay, and it has to be convex to do this. Okay, this is a practical method. Okay, so this is a triangle. How much are all these angles? They add up to 180. We know that, right? Okay, so the interior angle sum, these three angles of any triangle is 180 degrees. Okay, what about a quadrilateral? If you added up all four angles on the inside, the interior angle sum would always be 360. Okay, but if you draw this line, you can say that's 180 and 180 there. So you got two 180s, two triangles that are 180 each, and you add them up and you get 360. Interesting. Okay. Here's a pentagon. You could put two lines in that and have three different angles. 180, 180, 180 is 540. What do you notice about these three? How much is it going up every time? It's going up 180 degrees every time for the interior angle sum. Okay, and then a hexagon, you could have three lines, which means there's four triangles that are 180 degrees each. 4 times 180 is 720. It went up 180 again. Okay, so the interior angle sum, if you add up A, B, C, D, E, and F, okay, all those angles will add up to whatever this is. Do you know what N stands for? This is the formula. Okay, first of all, this is the formula for the interior angle sum of hexagon or any polygon, right? Okay, so this is the interior angle sum. 180 times n minus 2. What is n? It's the number of sides. How many sides does this one have? This one has 6 sides, right? Okay, so 6 minus 2 is 4. 4 times 180 is 720. Okay, so this angle, this angle, this angle, this angle, this angle, this angle all add up to 720. Any six-sided convex hexagon, okay, hexagon, all the angles add up to 720, even if it's smaller or bigger, they all add up to 720, okay, according to the interior angle sum formula. Okay, interior angle sum example. Okay, this one's 5-sided, right? So we plug it in here. 5 minus 2 is 3. 3 times 180 is 540. So angle 1, 2, 3, 4, 5 all add up to 540 if it's a pentagon. Okay? And then what if we're looking for just one single interior angle, like angle B? Okay, I want angle B. All right, but it has to be a regular polygon for that to work. In other words, all the angles, all the sides have to be congruent, and it has to be convex, right? Outies. So it's got to be all angles the same, all sides the same, right? Okay, so this is the formula. Now, if I marked out the n and it wasn't there, then isn't that just the interior angle sum formula? So all the angles, the sum of all the angles divided by the number of angles or sides, right? So if you divide this one by 6, whatever we had before, then it would work. Doesn't it make sense? Watch. Okay, the top, this is hexagon, so you plug in a 6 minus 2. 6 minus 2 is 4. 4 times 180 is 720. And then you just take that and divide it by the number of sides, right? And that would be 120. So every single angle is 120 degrees. Okay, simple enough, right? You get the sum with the interior angle sum formula, and then you divide it by the number of sides, and that'll give you what size each single angle is. Now remember, it has to be regular. All the angles and all the sides are congruent. Okay, here's a triangle. So all the angles would add up to what? I mean, we know just from the past that all the angles add up to 180 degrees, right? That's simple enough. Okay, so let's plug it into the formula and see if each angle is going to be how much? How much is it going to be? It's going to be 60, 60, and 60, right? So 60 should be the right answer. Okay, so we're going to plug in a 3. 3 minus 2 is 1. 1 times 180 is 180 divided by 3 is 60. So every angle is 60 degrees, which makes sense in an equilateral triangle. Okay, so now we're going to talk about the exterior angle sum formula, which is weird. You extend each side. You extend the side, extend the side, extend all the sides, and then the angle that's formed by the side and the extension is an exterior angle. Okay? Now there's an exterior angle sum where you take 60, 60, 60, 60, 60, 60 and add them up, and you get, well, I don't know. We'll do that in a second. Okay, what about a triangle? If you have 3 of them, then 120, 120, 120. What's that going to add up to? Well, I don't know. What about a quadrilateral? It's a 90, 90, 90, and 90 for exterior angles. What's that going to add up to? Obviously, what I'm trying to say is that they always add up to 360. The exterior angle sum always adds up to 360, and that makes it really nice, and you can do some stuff with that, okay? So this one's 360. The exterior angle sum here is 360. This one's 360. If you had a million-sided polygon that was a regular polygon, then every single angle added up would be 360 degrees. If you had a 30-sided shape, then the exterior angles would add up to 360 every single time. Okay, here we go. What if you wanted a single exterior angle? Now, it has to be regular so that all the angles are the same size, right? So if it's a hexagon, all of them add up to 360, right? So how would you find one angle? Yeah, if you said divide it by the number of sides, then you'd be correct. 360 divided by the number of sides, 360 divided by 6 sides, which is what a hexagon has, is 60. So each single angle is 60 degrees. Remember, we're talking about a single exterior angle, and it has to be a regular polygon, so all the angles will be the same size, right? Okay, what about this one? It's a triangle, so all the exterior angles add up to 360, right? So how many sides? Of course, a triangle has 3. 360 divided by 3 is 120. So each single exterior angle is 120. And then if you had a square, all the angles on the outside, the exterior angles, all add up to 360 divided by the number of sides, which is 4. It's a quadrilateral, right? So 360 divided by 4 is 90. So each single exterior angle is 90. Make sense? Okay, moving on. Okay, here's a nonagon, a regular nonagon. What is the exterior angle sum? It doesn't matter. It's 360. If it's exterior, the angle sum of any kind of regular shape is 360. So all of these angles on the outside add up to 360. Okay, what is a single exterior angle? Okay, these 4 questions are very important. This is like your quiz. Next time is going to be these 4 questions right here. Okay, a single exterior angle is 360 divided by the number of sides. Remember, this has 9 sides, so 360 divided by 9 is 40. So a single exterior angle, like angle D, is 40, or the one on the outside is. Okay, C, an interior angle sum. Do you remember the formula? 180 times parentheses. What's in the parentheses? Do you remember? 180 parentheses n minus 2. I put the n minus 2 in front, which is kind of weird. I'd probably throw you, but I want you to see it could be either place. Okay, so n minus 2 is out here. What does n stand for? Yeah, the number of sides. So if I want the interior angle sum, I'm going to plug the 9 in here because it's a nonagon. Okay, so I plug the 9 in here. Okay, so 9 minus 2 is 7. 7 times 180 is 1260. What is 1260 talking about? Well, it's talking about this angle, this angle, this one, this one, this one, this one, this one, and this one all added up. Okay, every one of them added up is 1260. Now, if I wanted to know what angle C was on the inside, the interior angle C, a single exterior angle, then I would take this 1260 or this n minus 2 times 180 and do what? Yeah, divided by the number of sides, right? Okay, so I plug the 9 in here. 9 minus 2 times 180 gives me that 1260, right? And then The 9 goes down here as well. And so 1260 divided by uh, 9 is going to be 140. So angle C is 140, angle D is 140, angle E is 140, all the way around. All the interior angles are 140. Okay? Exterior angle sum, all of them added up to 360 always. If you want a single exterior angle, you divide by the number of sides. Interior angle sum is a formula. It's like 180 times n minus 2, or n minus 2 times 180. A single interior angle is when you take this total right here and divide it by the number of sides. So 1260, which is this, divided by 9 gives you 140 for a single interior angle. Okay, now I'm going to show you this, but it's the long way and you're not going to use it. Because I had a kid, a smart kid, all y'all are smart, but he had a great idea and told me a little shortcut. He was a pre-AP kid. Anyway, wonderful. Okay, so the measure of an interior angle, okay, interior angle is 135. So that's the the formula for finding an interior angle, a single one, okay? And they said it was going to be 135. Now solve for n. That's a bunch of algebra, isn't it? It said find the number of sides. So now I've got to, okay, first of all, I've got to multiply both sides by n, and that gets rid of this n and this n. Okay? So now it looks like this. Okay? So now I distribute, and it looks like this. Okay, I've got n on both sides, so I need to, let me see, I need to, get rid of I usually get rid of the smallest n, so I'm going to get rid of that, which is minus 135n on both sides. That's 0 on this side, 45 on this side. Now I got to get this to the other side. Okay, it's okay to have 0. Okay, so I add 360 to both sides, so the 360 is over there, and this one disappears. Then I divide by 45, and 8. 8 is the number of sides, so this is an octagon. This is a long way to do this, right? Now here's what the kid told me. It was kind of his off-the-chain method, okay, outside the box method. So he said, what if you had, you don't know how many sides it has yet, but you draw a couple of sides like this, and what if you put the 135 here, which is what they said, it's an interior angle, and then you extended a side, okay, and then what would this one be? Yeah, this is 180 because it's a straight line, so 180 minus 135 would be 45. So the exterior angle is 45. All of the angles on the outside are 360 every single time. So 360 divided by 45 gives you 8. Octagon. Bam. Isn't that nice? Yeah, some kid told me that. I loved it. All right. So if you have the measure of an interior angle of a regular polygon is 144, find the number of sides. Well, same idea. You draw the picture. Anyway, y'all would be doing this in class. If you want to hit the pause and try to do it yourself, do it. Okay, but 180 minus the 144 will give you an exterior angle of 36. So 360 divided by 36 will give you, I've got it here. I didn't think it was on here. Okay, 144. The extended angle would be 36. So 360 divided by 36 is 10 sides. There's the answer. Yay. Easy, right? Okay. Now, this one has to do with interior angle sum, okay? All of these angles add up to a certain amount, okay? You can do the x's, but you can also, in a 5-sided shape, you can figure out what the angle sum is for a 5-sided shape every time, okay? So we want to find x, right? So how many sides do we have? Well, 5. Okay, we want to find the interior angle sum, so that's the formula, right? So how many sides? What do I plug in for n? I plug in 5. 5 minus 2 is 3. 3 times 180 is 540. So each one of these angles on the inside, there's 5 angles, all of them add up to 540. Okay, so 540 is equal to each one of these things, right? So x and 3x and 3x and x and x. So all of this is equal to 540, right? Each one of these adds up to 540. So I'm going to add these up, 3, 4, 7, 8, 9x. So that's 9x equals 540. Divided by 9, I get 60. Okay, so this angle right here is 60. This one is 60, and this one's 60. And what are these? Yeah, they're 180, right? Okay. And whenever I did this problem, I said to myself, yeah, something doesn't make sense here. This couldn't be a 180 because a 180 would be a straight line. So the numbers are bad, but I'm glad I made that mistake so people could see that. Anyway, you'd have to use something different than 3x. Okay? All right. But all of these add up to 540, so you can set them equal to each other and make an equation. All right. So this one right here, all of these add up to, is it 540 or what do we add it up to? Yeah, 180 times n minus 2. There's 4 sides, so 4 minus 2 is 2, so 180 times 2 is 360. So this time all of the angles add up to 360, so anyway, the interior angle sum is 180 times n minus 2. 4 minus 2 is 360, right? Okay, so 360, you would set all of these, add these 4 together, put them on this side. So that's 10x and 6x and 6x and 3x minus 15 is equal to 360. So you combine all the like terms, that's 16, 22, 25x, okay? Then you add 15 to both sides, right? The 15 goes over here to be 375, then you divide by 25, and isn't that like 15 quarters? Like if you're thinking 25 cents? Anyway, so x is equal to 15, all right? C is 15. Yay, we're done. Okay, let me kill it. Bye. Y'all have a great day. Have a great day. Kill it. Trying to kill it.